Hello, my friends, and welcome to exercise number 1. We are going to deal with the big O, so we need to find the upper bound for the function f of n. The first function that we have is 3f of n equal to 3n plus 8. Okay? This is the first function. We need to find the upper bound of this function. Okay? If we look on this function, what is the highest order of this function? We have two terms, the 3n and the 8. Okay? 3n, and here n at 8 times n to power 0, and here n to power 1. So n to power 1 is greater than n to power 0. So we took n to power 1 as the biggest symbol. And 3n plus 3n1, this means we remove the constant, and 3n plus 8 is less than 4n, because 3n plus 8 is less than 4n. If we neglect 8, 3n is less than or equal to 4n. It's true. And n, now we remove the constants. N is the notation O of n for the 3n plus 8. Okay? With c is equal to 4, c equal to 4, and n0 equal to 8. Okay? This is very important to understand. This is the first example. Don't worry, we will clarify in the next exercise. If we have the second function, f of n equal to n squared plus 1, what is the highest order of this function? We have two terms, n squared and 1, which is multiplied by n0. So we took n squared. N squared plus 1 is less than 2 to power n squared, because we neglect this and we add 1 to the same order. Okay? So n squared plus 1 less than or equal to 2 to power n square, 2 to power or n to power 2. Okay? For every n greater than 1. Therefore, the big O notation of this function is equal to n squared. It's very simple. We are just getting the highest order of the function, the highest n order of the function. Okay? And the c is equal to 2 here, 2, and n0 is equal to 1. This is the constant. It's very simple. Okay, guys? We are going also to make an example 3. So, find the upper bound for the function n to power 4 plus 100n square plus 50. Okay? So, please guys, think about it. This function f of n contains n power 4 plus 100n squared plus 50. How to solve this? How to find the upper bound? In the same way, look at this function. We have three terms, 1, 2, and 3. What is the highest order of this function? What is the highest n order of this function? We have n to power 4. Okay? So what is multiplied by n to power 4? It is 1. So this function, f of n, is less than or equal to, we increase the one that multiplied by n to power 4 by 1. 1 plus 1 is equal to 2. And the highest degree is n to power 4. Okay, so this function is less than 2n power 4. Okay, and n square here is the highest function. So O of n of this function is n to power 4. And the constants that we have is there are c equal to 2, because we have multiplied or we have added 1 to the one that multiplied by n to power 4. So this is equal to c, or this will determine the c, and n0 is equal to 11. Now, we don't care about these constants and n-zeros, because our all concentration about O of n. Okay? So I need from you to understand how to create or how to get O of n for every function. Okay? O of n here, it is O of n. Okay? This is the complexity. This is the big O notation. Another examples. Consider the function f of n here equal to 2n cubed minus 2n square. We have 2n cubed minus 2n square because we have two terms here. The highest term is n power cube. Since we have 2n cubed minus 2n square, so n cube 2n cube is being decreased. So this function 2n cube minus 2n square is less than or equal to n cube. We don't need to put here 3n like here. No, we don't need about to make this. We need to put 2n square, 2n cube. Okay? Because 2n cube is decreased by minus 2n square. So remember, take an example, n equal to 1. 2 minus 2 times 1 minus 2 times 1 is equal to 0. Is less than or equal to 2? Yes, because 0 less than 2. I substituted 1 inside this. We don't care about this function. We only care about the big O notation of this function. It is O of 3 because it is the highest degree. Okay? This is the big O notation of this function, where c is equal to 2, is the constant, and n0 is equal to 1. Okay? Now, another two examples that we are going to make in this exercise. Find the upper bound of f of n equal to n. N here is the only term that we have in this function. So, n is less than or equal to n. So, it is of big O notation. O of n notation. Okay? With c equal to 1, the constant equal to 1, because c is n is multiplied by 1 here, and n0 equal to 1. It's very simple. Let's choose another example. F of n equal to 410. 410 is less than or equal 410. Okay? It's very simple. 410. Now, this for all n greater than 1, this means 410 is equal to O of 1. So this is the O of 1. This is the notation of O of 1. Okay? With c equal to 1 and n0 equal to 1. So what we have done in this exercise is understanding the big O notation calculation for this for these functions. So how to calculate the O of n, how to get the highest degree of O of n in this exercise. So we have solved these O of n notations. It's very important to understand these and to learn about the O of n notation. And in the next videos, we are going to learn more about these notations and work with more exercises. So don't worry, we are going to make this very simple in the next videos when we deal with the complexity. So what I need from you to understand that big O notation for any function is the highest degree that it contains inside.